Okay, homework prep, Unit 6, Day 2. A couple things I want you guys to write on the top real quickly. When you're dealing with slope, it has a lot of other names as well. We talk about things like rate of change. Write this down with me. Or we use the letter M. You're going to see that quite a bit. Or we might see change in Y over change in X. You've already seen that. And some of you guys might have also seen rise over run. Okay? All those things mean the same thing. We call it slope, rate of change, M, and so forth. Let's go down here to the top right-hand corner where it has the equations. If you have the equation here, it's in a form called slope-intercept form, where you have y equals mx plus b or y equals b plus mx. Let me give you a couple of sample equations. Let's say I have y equals 4x plus 3, and let's say I have y equals 5 minus 1/2 x. In order to identify the slope from an equation, all you have to do is just look for the number that's snug up against the x, basically where the rate of change is. So here's the 4, or that negative 1/2 would be how we would identify the slopes. And you can see, of course, that slope will be negative because you are subtracting that 1/2 x. Okay? Bottom left-hand corner, let's talk about tables. If I want to find the slope from tables, we actually use a technique that we've already practiced in day 1. You want to look for that ratio that is the change in y over the change in x. Okay? So as we go through this, let's go down our table. So you can see here that as we go through our change in y's, that so far in the first 3, that these guys are changing by 2. And of course the x's are changing by 1. So far we have a ratio of 2 over 1. But if you look at the last row, that jumps from 11 to 15. We might initially say, since that's a 4, that this guy must not be linear, that there must not be a linear rate of change. But we also have to take into account the x. So here we have a ratio of 4 over 2. Well, 4 over 2 is the same value as 2 over 1. So here, our slope, or our rate of change, would be 2. Second table. Here we're going down by 2 on each one. On the x, we're going up by 3 on each one. So that is constant. Here our ratio, change in y over change in x, will just be negative 2/3, and that's our slope. All right, next one's a little tricky. Notice as you look down those y's, they're not changing. They're staying 4. So each one of these changes is 0. Okay, well, on the x, it's kind of jumping around a little bit. It goes down 8, up 5, down 3. So initially, by looking at those numbers, we would say there's no way this guy is going to be a line. Okay, but as you begin to write down the ratios, you might change your mind. Every one of these ratios, the 0 over negative 8, the 0 over 5, and the 0 over negative 3, all of them have a 0 in the numerator. Well, 0 divided by anything is just 0. This is going to have a slope of 0, and it will be a linear table. Okay? Let's turn our attention to ordered pairs. Ordered pairs are very similar to a table because a table is just is made up by just a bunch of ordered pairs. But if you have 2 ordered pairs, you can use what's called the slope formula. Write this down with me here. It says that y2 minus y1 divided by x2 minus x1 gives you your slope. Okay. Well, before we dive into that and I explain a little bit further, let me show you that you can take a pair of these ordered pairs and you can use the table just like we did above to find the slope. Okay. So for instance, down here at the bottom, let's say I made a little table, 2, 3, and 10, negative 2. And let's say I did my change in y over my change in x, just like we did up at the top. Okay. Well, my change in y there, I'm going down by 5. That's negative 5. And for my x, I'm going up by 8. What that leaves me with is a ratio that is negative 5/8. Let's see if that value matches the one that we get when we use the slope formula. In order to use the slope formula, you have to identify each one of the numbers as either x1, x2, y1, or y2. Well, this is the first order pair, 2, 3, so it has an x value and a y value. So we'll call that 2 x1. We'll call the 3 y1. For 10, negative 2, we'll call the 10 x2. And for the negative 2, we'll call that y2. Those help us identify what values to throw into our slope formula. So you'll notice the top says y2 minus y1. So negative 2 minus 3. On the bottom, you have x2 minus x1. So that's 10 minus 2. Okay. A little bit of math here. Negative 2 minus 3 is negative 5. 10 minus 2 on the bottom is 8. Well, looky there. We get the same value that we got with our table, negative 5/8. Okay. Let's try the slope formula again with the order pairs on the right. Take that first order pair, negative 3, 5. Make the negative 3 x1. Make the 5 y1. Make the 1 for the second order pair x2. And make the 6 y2. And let's use the formula. Okay, well, y2 minus y1 gives me 6 minus 5. x2 minus x1 gives me 1 minus a negative 3. Okay, so we've got to be careful with those two negatives, but I think we can handle it. M equals, let's see, 6 minus 5 is 1. And then 1 take away a negative 3. That's like saying 1 plus a 3. So that leaves us with a slope of 1/4. Okay? Now I want to attack the graphs over here to the right. Before we do, I want to talk a little bit about that slope mountain stuff up here at the top. Okay? The slope mountain is just a visual aid that we use to help us remember some relationships about the slopes of a graph. This is kind of a weird mountain. There is, as you go from left to right, you can see here that this is going up the mountain there. That would be a positive slope. This part right here is coming down the mountain. That'll be a negative slope. So those aren't too tough. The ones that folks struggle with is that vertical part and the horizontal part. Okay. On the vertical part, there is no slope to ski on. You can't ski on that. You're just falling. Okay. So for that one, we would say that there is no slope. You'll also notice that that vertical part is not a function. So you can see that the no and the not correspond. No slope, not a function. Okay? On the horizontal part, even though it may not be a whole lot of fun, you could imagine a little skier down there with his skis, and he could stand up on his skis and ski. Now, gravity's not there to help him go down the mountain, but you could maybe like cross-country ski. So there is a slope there to ski on. It's not positive, it's not negative, it's in between, it's neutral. It is a zero slope. You'll also notice that that would also be a function. Okay. We're going to use these here in a moment to double check our answers we get from our graph. Okay, let's go to the first graph over in the bottom right. In order to find the slope of a graph, you need to identify 2 points that are on that line. Okay, and it can be any 2 points in the line. And what I recommend is find points where the line crosses through the corners of the grids perfectly. For instance, you could use any one of these points here. You'll see me almost 99% of the time, if I have a point that's on the y-axis, I'll try to use that point. So let's choose that point, and then one of the points around it. Let's say this guy right here. Okay? And what I want to use is, I want to use my rise over run. So I want to figure out how much I'm going up or down and then side to side in order to get from one dot to the next. Okay, so let's say that on those two blue dots, let's say that I want to go from the left dot to the right dot. Okay, so first I would have to go up 1. That's 1. So that would give me a rise of 1 because I'm going in the positive direction. Then I want to run 3. Well, that takes me 3 in the positive direction. That would give me a slope of 1/3. Up 1, right 3. But then you might say, whoa, 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 Mr. G, what if you went the other direction? Okay, well, let's do that. Let's say I go from the right dot to the left. Well, in order to do that, I would have to go down 1, so -1, because I'm going in the down direction. Then left 3. Well, that's -3. So you end up with a slope of -1 over -3. Well, remember, a negative divided by a negative is a positive. So you should end up with 1/3, just like we did in the other direction. Also notice that that line is going up the mountain, so we should expect to get a positive slope. All right, second graph. Let's identify some points here we can use. Okay, let's see. I could use this one, any one of these points here. So there are a bunch to choose from. I'm going to use the one on the x-axis, the y-axis, and some other point. Let's just make it random. Let's say it's this one. And I want to find the slope going from the dot on the left to the dot on the right. Okay. My rise here would have me going down 6. So since I'm going down 6, that's negative, in the negative direction. And then right 3. That 3 is in the right direction, that's positive, so I get a positive 3. Well, -6 divided by 3, that's a negative divided by a positive. I'll end up with a slope of -2. Notice that that line's coming down the mountain, so we should expect a negative slope. Let's go the opposite direction. Let's say I go from the dot on the right to the dot on the left. Here I'll go up 6 and then left 3. So +6, -3. Here I still have one that's positive and one that's negative. So my final answer will still be a negative slope or a -2. And of course, those match up. Okay, next graph. Whoops. Okay, let's pick some order pairs we can use here. Remember, we're looking for where this graph is going to go through the corners of the grid perfectly. So I could use those points there. I'm going to use the point that's on the y-axis and one other point. So let's say, just being random here, let's say those two. Okay. Over here, I'll go left to right. So this is up 2, right 6. Okay, so that gives me 2 over 6. I can reduce that. That gives me a slope of 1/3. Let's go the opposite direction. Down 2, left 6. So that's -2 over -6. All right, negative divided by a negative, I get a positive. It's 1/3. I'm going up the mountain, so I should expect a positive slope. I'm feeling pretty good. All right, last one. Last one looking pretty weird. Notice that there isn't a y-intercept here, but there are a bunch of points here I could choose. Let's just say I chose those two that are on the grid. And let's say I want to go here. I can't really go left to right. But let's say I wanted to go top to bottom. So here I would have a rise down of -7. Okay. But then when I tried to do my run, my side to side, it doesn't go side to side. So there's no change there. That would just be 0. If I try to divide -7 by 0, it wouldn't make any sense. Matter of fact, if you plug that into the calculator, you get an error. There is no value here. There is no slope. Okay. Let's try the other direction. Going up. Well, that gives me a +7 going up. Once again, I have no side to side. I can't divide 7 by 0. It doesn't make any sense. There is no value there. There is no slope. And notice this also corresponds to that vertical part of the slope mountain. There is no slope there for the skier to ski on. Okay. Hopefully this helps as you guys come in the classroom on Thursday and Friday to find slope. I wanted to give a shout out to 4th period. They were the first ones to ask for a shout out, so that does make them trendsetters or bedwetters. I can't remember which one. Either way, I'm big fans. All right, so you guys have a great evening.